Okay, this is the fifth video. We're going to be solving exponential and logarithmic equations. Here are the objectives and the strategies that we're going to be using here, and let's just move on. Once again, we're going to use the one-to-one property as our first strategy. What this says here is that if I have the bases are the same in both of these, a to the x equals a to the y, if and only if, and that means both of these are true, they both have to be true, if x equals y. So what that means is if I can write both sides of the equal sign with the same base, then I can say that the exponents are equal. You can do that with logarithms as well. Notice that the bases have to be the same. So if you're taking log to the same base, then x and y have to be the same amount. All right, so some examples here. 2 to the x equals 32. 2 to the x equals 32 is 2 to the fifth power. Because they have the same base, they are 1 to 1, and so x equals 5. All right, in this example, what I want to do is I want to say the natural log of x, and then I'm going to add to the other side the natural log of 3. Notice that these both have the same base, so x equals 3. Another strategy is to use the inverse property. So, in other words, here, if I have the log to the base a of x, to do the inverse of this, I will take a, same base, to that power. And when you do that, the exponent log to the base a of here, you end up with the value x. And then same thing here. If I have a to the x, if I log this side, it's going to equal x. And so we're going to use this here. So we have e to the x equals 7. So I'm going to do the inverse operation. And I'm going to natural log both sides. Using the power rule, the x will come in front. Natural log of e is just 1. And so x is going to equal the natural log of 7. I can do that over here for this one as well. I have a logarithm, so I can exponentiate, which is that word. Notice that the base is 3, so I'm going to take 3, I'm going to take it to a power, exponentiate. This part right here, since that's the inverse, is going to be 1, and x is going to be 3 to the 4th, which is 81. Here's another example. This one's going to require that you have a calculator, so I hope you have one handy. I think I do. We want this equation to say 2 to the x equals a number. And so the first thing that I'm going to do here is divide both sides by 3. And that leaves me 2 to the x equals 14. In order to solve this, since it's an exponent, the inverse, I'm going to use the inverse property. So I'm going to log both sides. Remember that the power rule allows me to write the exponent in the front, so x times the log of 2 equals the log of 14. These two logs still have the same base. And remember, log of 2 is just a number, so I'm going to divide the log of 2 from both sides. That's a form of 1. And x is going to equal, I've got my calculator over here, log of 14, close the parentheses, divided by the log, hit log again, of 2, and hit enter, and I get 3.807354922. You know, just a nice little rounded even number. This one you can use the one-to-one property because they are both e to a power. So because these are both e to a power, that means that their exponents are equal to each other. So negative x squared is going to equal negative 3x minus 4. I'm going to move the x squared to the other side to make it positive. So 0 is equal to x squared minus 3x minus 4. I believe this will factor. So I'm going to have a 4 and a 1 because of the middle number, and then it's negative, so this will be yes. All right, so my two variables, my two answers, are going to be x equals -1 and 4. Now, it's possible that it could have two answers. It's also possible that I might have something you need to check for I might have something extraneous. So we need to check for extraneous answers. Anytime you have a squared, you possibly could have an extraneous answer. Okay, so I'm going to put in e to the -1 squared equals e to the -3 -1 minus 4. Okay, so this is -1 squared, so this is e to the -1. This is 4 minus 4, which is e to the 0, which is 1. They do not equal, so this is not an answer. That's not a solution. If I have e to the -4 squared, e to the -3 times 4 minus 4, this is 16. E to the -16 equals e to the -12 minus 4, which is -16, and that is an answer. So -1 is extraneous, and the 2 is the actual, the 4 is the actual answer to this equation. You can see that checking your answers is going to be very, very important. Making sure that the two answers or one answer that you get is actually a solution to the problem. I have written out here an example that you can see with the words next to it. The original equation was the natural log of x equals 3, and that's written in logarithmic form. Exponentiating each side, knowing that that's the natural log, so I'm going to exponentiate e, both sides. E, when you do that, the e and the natural log are inverses of each other, so they become 1. So this is x, and then this will be e to the 3rd power. You can do the same thing with the problem down here below. This is the natural log of x equals 2, so I'm going to exponentiate both sides. And you have to do both sides, and that's where students get in trouble, is when they only exponentiate one side. So there's another example. Okay, here's a final example. This one we're going to be using the one-to-one property. And the reason it's one-to-one property is because the bases of both logs are the same. So the one-to-one property says if the bases of the logs are the same, then the values of these are also equal to each other. So I'm going to set 5x minus 1 equal to x plus 7. I'm going to subtract the x to the other side, so 4x. I'm going to add the 1 to the other, and x is 2. Okay? So when I just do a quick check to double check that it works, what I'm really looking for when you plug in an answer into a logarithm is that you want to make sure that you are not trying to take the log of a negative number. So if I were to put a 2 back in here, this is a pretty simple problem, but if I had a problem like this and I put a 2 back in there and it became negative in either this argument or this one, then this would not be a solution and there would just be no solution. So if the one and only solution makes it incorrect or makes it negative in the argument here, then that would just be no solution. All right, copy these 4 problems down in your composition notebook. You need to work these. These are your 4 problems for homework. They are similar to the examples that we went over in this video. Be sure that you're doing these problems. This is an opportunity for you to learn this material in a deeper way maybe than you have before. See you in class.